April 17th, 1945, Lieutenant William Holden of the 3rd Marine Aircraft Wing of the U.S. Marine Corps Reserves took off from the island of Molokai in a Corsair F4U airplane. He was ferrying the plane to the Marine base in Ewa on the island of Oahu, and 20 minutes into his flight, his plane had a mechanical problem and he lost power. He had to ditch his plane in the water, and he was safely rescued, suffering only a cut over his right eye. His Corsair sank a few miles south of the island of Oahu, and that's where we're diving today. The Corsair is sitting upright in just over 100 feet of water. One of the wings is submerged under the sand, but basically all parts of the plane can be seen. For wreck diving enthusiasts and aviation history buffs, seeing a Corsair completely intact underwater is really special. This is a plane that was crucial to the United States' success in World War II and flew thousands of combat missions over the Pacific. From a biological perspective, what's interesting about this wreck is that it sits in basically a desert of sand, far enough offshore that there's really no structure around, really no coral reef in the area. But the plane represents the one solid piece of structure that fish and invertebrates can use as their home. Some really interesting animals use the Corsair as shelter. Since it's surrounded by sand on all sides, a lot of the animals that shelter here are animals that feed in the sand. Just off one of the wings, there's a field of garden eels. Garden eels stay in their burrow and extend their body and head up into the water column and pick off plankton that's drifting by in the water, and that's how they feed. If you approach them too closely, then they descend into the sand and hide in their burrow. Filming garden eels is quite tough because they don't allow you to get very close. So we set one of our POV cams in the field of garden eels, and then we were able to leave and got some interesting footage that way. One really interesting fish species that uses the Corsair as shelter are these goatfish. The distinguishing feature of goatfish are the two barbels that come off of their chin. And they use these barbels to sift through sand and other sediment to look for worms and crustaceans, other food items that they can dig up out of the sand, kind of scare out of their burrows and eat. Really amazing fish to watch at work. The Corsair has been underwater for 65 years now, and that gives us an opportunity to look at the rate of coral reef growth at a depth of 100 feet in the offshore waters of Hawaii. You can see it's basically completely covered with coral, algae, a variety of invertebrates. But in 65 years, it remains intact. You can obviously tell that it was an airplane, but it's now become home to a whole community of organisms. At a depth of 100 feet, there's a lot less available sunlight. Reef-building corals have algae living inside of their tissue. This algae requires sunlight to photosynthesize, which provides energy for the coral animal. And without adequate sunlight, these types of corals can't survive. At 100 feet, we're right on the edge of the depth limit for these types of corals. If the Corsair was much deeper, none of these corals would be able to grow. One thing you'll notice looking at the images, at a depth of 100 feet, the quality of light changes dramatically underwater. As you descend, the first color that's removed from the color spectrum is red. As you descend deeper, eventually all that you're left with are dark blues and grays. And at a depth of 100 feet, we're really limited to those parts of the color spectrum. We dive with artificial light, and in close-up situations that allows us to illuminate our subjects and show colors that you don't see underwater with your naked eye. It requires really bright lights to bring out these reds and oranges and browns, beautiful colors on the reef, often unseen without the aid of light. Diving to 100 feet poses some challenges for our film team. We're limited as to how long we can stay at that depth. As you stay underwater, nitrogen builds up in your bloodstream, and it can become dangerous if you go too deep or stay too long. At 100 feet, we have about 15 minutes of time that we can spend on the bottom, so it's important for us to be as efficient as possible. Get down, do our film work, and get up before too much nitrogen builds up in our bloodstream.